Good morning, you guys. I hope you all are well and managing this homeschooling okay. You may or may not have a mini quiz this week on inequalities, polynomial inequalities, so I wanted to give you a review, just 2 quick questions. This is what your quiz would look like, walk you through both of the problems, and give you some tips on how to solve them, okay? So there's no additional assignment. Feel free to continue working on that worksheet. Reach out to me if you feel like you need additional practice, but I'm hoping that you have enough between this, the worksheet I posted, the video I posted, and then your pre-calc teachers, okay? All right, so you're going to be presented with some sort of a polynomial inequality. You want to make sure it's set equal to 0 or the inequality to 0. And think of it as an equation when you're solving. You don't have to think of it as an inequality as you're solving. So this first problem, we just have a quadratic, factors of -5 that add to -4. So we can factor this to x minus 5 and x plus 1. So that would give us 2 critical values of 5 and -1. The other thing I encourage you to do, once it is set equal to 0, put it in your graphing calculator or Desmos. So x squared minus 4x minus 5. Right, so there's our graph. And the inequality wants to know, where is it greater than 0? In other words, where is the graph positive? Visually, we can see it. I can't write on top of Desmos, but if you can see the 2 x-intercepts, which we just solved for, -1 and 5, and above them, the parabola is stretching on forever. In between them, it's below the x-axis. So in between is where it's negative, and on the outsides, and visually speaking above them, is where it's positive. So let's see, how do we come up with the inequalities? How do we come up with our interval notation showing this solution? Well, you come up with a number line. You break a basic number line into intervals using your critical values. So we have a -1 and we have a 5. You can throw other key numbers on there like 0, -2, 6, because maybe those are the numbers that you'll use to test. I suggest using your factored form because all we're looking for is, what's the sign? Is this number going to be positive or negative? Because we just need to know, is it above 0 or below 0? So if I plug -2 into the factored form, -2 minus 5, well, that's a negative number. -2 plus 1, that's a negative number. A negative times a negative will give me a positive. So now if I try the same thing with 0, 0 minus 5, that's a negative number. 0 plus 1 is a positive number, so a negative times a positive will give me a negative. And then if I plug in 6, 6 minus 5 is positive, 6 plus 1 is positive, positive times positive is positive. So the solution to this inequality, since we want to know when it is greater than 0 or when it is positive, are on the outsides of the graph, just like we saw on the Desmos graph. So we want to be careful now. It's just a greater than. It's not an equal to. So we're going to use parentheses, interval notation from -infinity until -1, union, parenthesis, 5 until infinity. That would be the answer to this inequality. Okay. Okay, number 2. So it starts off looking a little different. It's also a cubic rather than a quadratic, so that means that we could expect 3 solutions. It's not set equal to 0, so we have to do that first. So we're going to move the 6x over, and we have something like this. X cubed minus 6x is greater than or equal to 0. We can graph the left-hand side of this to get an idea of what does it look like. So we want to know, where is it positive? Okay, so that kind of gives us an idea. There's one, it sort of looks like part of a parabola between -2.449 and 0. That is positive. It's above the x-axis. And then we're above the x-axis again on the right side, or above 2.449. So let's see, how do we get those solutions? How do we get those intervals through solving? Okay, so again, think factor. This is a GCF. I can factor out an x I'm left with an x squared minus a 6. Just set it equal to 0. Ignore the inequality sign when you're solving. Don't forget about x equaling 0, and then x squared minus 6 equals 0. I can't factor x squared minus 6, but I can solve using a square root. When you use your square root, use plus and minus. Okay, so now I have 1, 2, 3 solutions. Just like my graph showed, I have 3 x-intercepts. Number line. So I found my zeros already on my graph, so I know that they're roughly negative 2.4 and 2.4, but you can put them on here as negative root 6, 0, and root 6. Even if I hadn't gone to my graph and found the exact decimal value, I would know that this is between 2 and 3, right? Because 2 squared is 4 and 3 squared is 9, so it falls somewhere in there. That's all I really need to know. So I'm going to pick a test value that's, negative 5, far away from negative root 6. And then I can pick a test value like negative 1. Let me write these in red so we know that they're not critical values. Positive 1 and positive 5. Go to your factored form. It'll be the easiest to think about in terms of the positive and the negative. So negative 5 going in there. The x that stands alone, obviously that's going to be negative. And then negative 5 squared, 25 minus 6, that's a positive number. So a negative times a positive is negative. If I use negative 1, the x that stands alone is negative. Negative 1 squared minus 6 is negative. So double negatives give me a positive. Positive 1. 1 is positive. 1 squared minus 6 is negative. Positive times a negative, negative. And then 5. 5 is positive. 5 squared minus 6, positive. So we have two regions, two intervals, where it's positive, just like the graph showed, between negative root 6 and 0, and root 6 on to infinity. This time I have an equal to symbol on my inequality, so it's a bracket, negative root 6 until 0, union, bracket, root 6 until infinity. Infinity does not get the bracket. So again, between negative root 6 and 0, this whole region in there, and then again from root 6 to infinity. That portion of the graph is positive. Okay, so this is what your quiz would be like this week. This is all that you would be doing this week in pre-calc as far as I know. It's what was shared with me. So when we return, you'll pick up right here where we left off, I believe. There's a little bit more in this section, which is why this is just a mini quiz. But hopefully you're happy that trig is over and you're moving back into more algebra-based stuff. And if you need anything from me at all, please feel free to reach out. We can absolutely set up a Zoom. You can ask me questions, and we'll get through this. If you have things that are missing and you want to work with me this week, let me know. Otherwise, there's really not much for me to be posting. I don't want to add excessive work if we don't need it. Okay, so I'll post this as a worksheet for you, both blank and filled in, and I'll post this video. Okay, take care, and if I don't talk to you or hear from you, enjoy your spring break.